guys, welcome back to my channel. Our topic for today is orbital theory, but before that, let's start with the homework from the previous video. So number 1 is A, which was methylamine. Why? Because they have a nitrogen atom, and do you remember FON? So the nitrogen can bind with hydrogen, forming a hydrogen bond. Number 2, we have carbon sulfide. Now this is a covalent bond. Why? Because carbon is in the 4th group in the periodic table, so it's more likely to form covalent than ionic bond. Number 3 is ammonium chloride. There are 2 bonds involved here. One is with the 4th hydrogen atom, which is dated covalent bond. The nitrogen donates a lone pair of electrons. And the second one is with chlorine atom, which is ionic bond, because chlorine is in the 7th group in the periodic table. And for the last one, the answer is C. Why? Because acetic acid has a greater molecular mass. It is heavier, it is larger than the other 2, and this is why it has greater London forces. Now, starting with today's topic, we'll speak about valence. Now, an atom's and element's valence, you can also say that, to make it easier, is the oxidation state or the oxidation number of this element. And some of them are fixed, while some of them change. Right? So the ones that change, they are transition metals or elements, and the ones that do not change, they are just metals or like elements. Okay? So some examples of transition is copper. You have +1 and +2 forms. They can differ. Then you have iron, +2 and +3. Then you have chromium, which is +2, +3, also +6. It can change. You have manganese, which can be +2, it can be +7. All right. Then we have, I'll split it for you into cations and anions. Some of them that you need to know because they are fixed. You need to know them. So cations are the positive ions with a positive oxidation state, and anions are the negative ones, right? So some examples of cations. Please do learn these numbers. You're expected to know them during the exam. So zinc is always +2. Then you have aluminium, which is +3. Sodium and potassium, they're in group 1 of the periodic table, so they're +1. Magnesium, calcium are in group 2, so they're +2. Then you can have silver, Ag +1, gold is also +1, etc. And you can also have hydrogen, the main one, which is +1. Now moving on to some anions, you have the halides, which are chlorine, bromine, iodine, fluorine, they're all -1. Then you have a hydroxide ion, which is -1. You have nitrate ion, which is -1. You have sulfate, which is -2. You have carbonate, which is -2. Oxygen is -2. Cyanide, -1. And that's all for now. Now I'll teach you how to draw an orbital diagram. Alright, so in the exam, they will give you an element and they will also give you the number of electrons. You need to know this in order to draw the orbital diagram. So you have to draw it. These levels are drawn according to increasing energy levels. So you have a small box for S and you have a bigger box for P. I don't know if you've heard this before, but this is the order. So you have 1s, which has, you can fill 2 electrons on a small s, then you have 2s2, you have 2p6, and then you have 3s2, and so on, then 3p6, then 4s2, etc. In each box, you can fill 2 electrons, a pair of electrons, and they have to be in opposite directions, because the spin in opposite directions, it will be wrong if you draw it like this, or even like this. So you have to only draw it like this. This is the only correct way. For P, you have to fill each small box individually before completing each small box. So this is 2, 4, 6, 8, 10, 12. There are 12 electrons in this element. Now here's something called electron configuration, and this is writing like what you see on the orbital diagram, doing it in written form. So looking at the diagram, you can see that there are 2 electrons and 1s2. So you're going to write 1s2, 2s2, 2p6, and then 3s2. If the 3s had only one electron, it would become 3s1. Remember, you're always given the number of electrons, so don't worry about that bit. Okay, now we'll move on to the second part of this video, which is molecular orbital theory. Now, molecular, from the name, you can say that it is for a molecule, not for a single element like it was for orbital diagram. Okay, so if we take only nitrogen on its own, and we can only draw an orbital diagram for it. But if we take a nitrogen molecule, we have to draw a molecular orbital diagram. Okay, and the electrons will be given to you, as I mentioned earlier. One nitrogen has 7 electrons, so 2 will be 14 electrons. All right, so for molecular, you have to know the orbital diagram, and to make it easier for yourself, I'd suggest you draw the orbital diagram on the side. So let's draw it. You have 1s2, 2s2, and 2p3. Why? Because we have 7 electrons, so 2, 4, and then 3 in p, which is 7. So for each nitrogen atom, you will draw one orbital diagram on one side and one on the other side. Molecular orbital theory needs 1s2 individually, a diagram for each orbital. The same for 2s2. The s's look like this. You have 2 squares. The squares are from the orbital diagram and the circles are for the molecular orbital diagram. So you have to label each square being 1s2 and 2s2. The bottom circle is sigma and the top one is sigma antibonding, which is denoted with an asterisk or a star. The same goes for the 2s2. Now you have to fill the orbital diagrams first. So 1s2 is for the first nitrogen. The second one is for the second nitrogen atom because it's a molecule. You have to fill them. Now first you always fill the bottom one, which is the bonding orbital, and then you move on to the antibonding. So you have 4 electrons, 2 go down and then 2 go on the top. The same for 2s2, 2 down and 2 on the top. So 1s2 is done, 2s2 is done. Now we need to move on to 2p3. So this is how you draw. So first you draw the orbital for one nitrogen atom on one side, then you draw the orbital for the other nitrogen atom on the other side. Then, because you have 3 small squares, you need 3 circles as well. Now, they're arranged according to the energy level. So first you have 2 pi's, which are at a lower energy level than the sigma, and then on the top you have sigma. So again, you have bonding and antibonding. It is drawn like this. So we have 3 electrons in these p orbitals, and together both the orbitals will give you 6, right? So first you have to fill the bonding, as I mentioned earlier, then only you can move on to the antibonding shells. So we have 6. You start always with the lower energy level, so we start with pi, and you have to fill each orbital first before you move on to complete the orbitals. So you have 2 electrons each in each of the pi orbitals, and then you have a pair in the sigma, and you have 0 electrons left for the antibonding. Okay, so when you get this question in the exam, you have 4 parts. So A is drawing the molecular orbital theory for the element, the diagram. Second is the electron configuration, which I'll show you in a little while. C is the bond order. Now the bond order is equal to the number of electrons in the bonding shells minus the number of electrons in the antibonding shells divided by 2. So here we can say, see that the number of electrons in the bonding is 2 in 1s2 plus 2 in 2s2, then 6 in 2p3, right? So you have 2 plus 2, 4 plus 6, 10. The antibonding is 4, 2 from 1s2 and 2 from 2s2. All right, so 10 minus 4 divided by 2 is 3. So that's the answer for the bond order. Then part D is whether it is paramagnetic or diamagnetic. What does this mean? Like, you have to look at the last orbital that you just filled, right? So in this diagram, we can see that the last one is our sigma from 2p3. So if there are 2 electrons, if there is a pair, it is diamagnetic. If it is single, if there is an unpaired electron, then it is paramagnetic. Here we can see that our sigma is completely filled, so we're going to say that nitrogen is diamagnetic. And now I will show you the electron configuration. Since we have different labels here, the electron configuration will differ a bit. So we have bonding and antibonding. So the first was sigma 1s2, then sigma antibonding 1s2, then sigma 2s2, then sigma antibonding 2s2, then we have pi 2p 4, then we have sigma 2p 2. To make sure that you have got it the right way, you have to count the number of electrons on the top. So you can see 2, 4, 6, 8, 12, and 2, 14 electrons. So you know you've got it right. Now we'll move on to the homework. So I'll give you just 2 questions. First is please draw the orbital diagram, which is for a single element of oxygen. And my second question will be, please draw the molecular orbital diagram for a molecule that is boron. And the number of electrons for boron is 5, and the number of electrons for oxygen is 8. Remember molecular orbital diagram, so the boron will not be 5, but it will be 10 electrons. And that will be it for this video. Hope you enjoyed it. See you later. Bye.